Hey class, Mr. Houston here, back with another exciting talk about circles. Today we're going to be talking all about inscribed angles and polygons. What is an inscribed angle, you may ask? Well, this is an inscribed angle. Instead of the angle being formed at the center of the circle and projecting out, an inscribed angle is formed on the circle itself. And then we also talk about what's known as an intercepted arc. So if we extend out the sides of that angle, the arc that is created by those lines is known as an intercepted arc. How are we going to use them? Well, here's how we are going to use them. The measure of an inscribed angle, so this part here, is 1/2 the measure of its intercepted arc. All right, actually they have it down here for us. So the measure of ADB is 1/2 the measure of arc AB. Okay, just to kind of piggyback off of that, the measure of arc AB will be equal to 2 times the measure of angle ADB. Okay, so just think of the angle being half as big as the arc in that term. Alright, so let's do a little math involved here with it. So the first thing they want us to do is find the measure of angle T. So angle T is right here. Angle T is the inscribed angle. Okay, so to find the measure of angle T, it is going to be 1/2 times the measure of arc RS. So arc RS is 48 degrees. So 1/2 of that will be 24 degrees, and that'll be the measure of angle T. Alright. Now on the flip side of that, they're going to give us the inscribed angle, and they want us to find the measure of arc QR. Now this is going to take a little bit of doing because the first thing we need to do is we first need to identify that R to T is a semicircle, so this entire thing is 180 degrees. This 50-degree inscribed angle will go with arc QT, and if we remember from our notes up here that we just talked about, to find an arc measure we double the inscribed angle measure. So QT is going to be 2 times 50, so arc QT is going to be equal to 100 degrees. We know that TR, or arc TQR, is equal to 180 degrees. So in order to figure out arc QR, we are going to take 180 minus 100 to give us 80 degrees. Alright, so we do have to do a little bit of math there just to understand what they're asking us there. Always look for a diameter to give us a semicircle, which will give us our 180 degrees that we used. Okay? Alright, so still using inscribed angles, intercepted arcs. Then this one, they want us to find the measure of arc RS and the measure of arc STR. So let's do that first before we do anything else. So arc RS, notice that it's across from this 31-degree angle, so the measure of arc RS is going to be 2 times 31, which will be 62 degrees. And then they want to know what we notice about arc STR. So STR, remember that a circle is 360 degrees, so STR is going to be equal to 360 minus 62. Oop, not equal to 62. Let's back that up here a little bit. Minus 62, which will be 298. Okay. So, we notice that RS is 62 degrees, and then the STR is going to be 360 minus 62. Now the last thing they're going to ask about this is, what do you notice about STR and RUS? So STR is the one we found, which was 298, and then they're asking, what do we notice about RUS? Well, RUS is the same thing, just in reverse. So STR and the measure of RUS are both going to be equal to each other. It's basically just like naming an angle. You could name it one way or the other. It would still have the same value. Okay, so just kind of keep that in mind as we flip our paper over and take a look at Theorem 10.8. So, if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So, just to give you a visual here, I don't want a highlighter, I'd like a pen. So we have an inscribed angle here that creates this arc, and we have an inscribed angle here that creates that same arc. Those angles have to be congruent. And I mean, think about that. If say angle ACB was 25 degrees, giving us a 50-degree arc out here, then angle D would also have to be 25 degrees because the angle measure is half the arc measure. So just keep that in mind. Alright, so something they may ask you on your standardized test is name all the pairs of congruent angles in the figure. So remember, congruent angles will be ones that intercept the same arc. So I find it easiest to just extend out and see what arc is created. Okay, so that arc is there. I see also here that if I extend these out, this arc is created. So in looking for our answer, we need KJL, which I see here, is congruent to KML, which I see here. And I don't see those necessarily anywhere else. So right now, even without doing the other one, we know that C is going to be our answer. But how we arrive at C is that we also need to look at the angle that is created. Let's see if I can. You have this one here, which will create this arc, which will also give us, let's change colors here real quick. Then you can also see this one here, which will give us this arc. So these will be congruent. We also saw that this angle was congruent with this angle. Alright, so lots of inscribed congruent angles that we can find there. Alright, so a couple of theorems here. The first one we'll just talk about briefly. If you have a right triangle inscribed in a circle, so inscribed means it's inside the circle. If you have a right triangle inscribed inside the circle, the hypotenuse must be the diameter. Okay, so on the converse of that is if one side of an inscribed triangle is a diameter, then the triangle is a right triangle. So if you have a line going through the diameter, this is going to be a right triangle, and this will be your right triangle, or your right angle right there. Okay, so that's Theorem 10.9. Theorem 10.10 says that if you have a quadrilateral inscribed inside a circle, and that can only happen if opposite angles are supplementary. So as they describe it here, measure of angle D and the measure of angle F. So here and here they must add to 180 degrees, and here must add to equal 180 degrees. And that's the only way it works out when it's inscribed inside a circle. And so that's what we're going to do here with the last example, is just try and solve for different variables with quadrilaterals inside a circle. Alright, so example A, we are going to try and find x and y. So I'm going to do y first. And remember, it's opposite angles, so they shouldn't be touching. So we know that 75 plus y should equal 180 degrees. We'll subtract 75 on both sides. we'll get y equal to 105. Same thing with x. It's got to be opposite, which will be 80. So 80 plus x equals 180, minus 80 on both sides. X in this case has to equal 100. Okay, so now you could check all of your work by knowing that a quadrilateral has to add up to 360 degrees. But obviously, if you found the supplement to both of those angles, they'll add up to 180 for each of them. Okay, so now we're going to try and do something a little more difficult. We're now going to give you variables with each of them. Again, still opposite angles. You simply are just still going to add them. So 4b plus 2b equals 180. Combine your like terms. We're going to get 6b equal to 180. Divide both sides by 6. B in this case will be equal to 30. Again, do the same thing with the opposites. 2a plus 2a equals 180. Combine to get 4a. Divide both sides by 4. And you will get a equal to 45 degrees. All right. So lots of information going on here. Nothing that is too terribly new other than the inscribed angles and such. But just make sure you understand what is congruent, what isn't congruent, what has the same length, what doesn't, and hopefully it makes a little bit of sense for you. If you have any questions, bring them with you to class, and we will see you then.